Hey kids, today we're going to learn about calculus with basketball. Since we already know how to measure how far the ball goes in the air and how high it goes in the air, have you ever wondered how to find how far it actually travels through the air in a curve? Stay tuned to find out. So, in order to solve our basketball conundrum, we first need to know about derivatives and integrals.
But Nill, what's that?
Well, it's a really important part of calculus, which was invented by Gottfried Leibniz and Isaac Newton in the 17th century. Now, as I was saying earlier, the two main things that we need to know to solve our basketball problem are the derivative and the integral. Now, the derivative is a really important part of calculus, and usually we would use it to find the instantaneous rate of change. Now, thinking about that graphically, let's say you had a curvy graph. The derivative would help you find the line tangent to any point on that graph. It's really amazing stuff. And the next thing we need to know is the integral. Now, the integral can be thought of as the antiderivative. And we would use the integral generally to find the area under the curve, or the sum of a lot of small parts. Now, the integral and the derivative working together will help us solve our basketball problem. We'll be able to use both of those to find a formula for arc length. So instead of measuring the path of our basketball with a string and just guessing and checking, we'll actually be able to solve it using calculus. Now, the first two things that we'll need to do are somehow find a way to fit these into a formula together so that they can... So we will need to figure out how to put these two things together, and we'll need to find out how to apply it to find the arc of our shot.
Explanation time! Alright kids, so here's where the math gets all nitty gritty. First we're going to start with the distance formula, which you should already know. D equals the square root of y2 minus y1 squared plus x2 minus x1 squared. Now you can see that y2 minus y1 and x2 minus x1 can be written as delta y and delta x. If we're thinking in terms of calculus, we can replace those delta y's and delta x's with dy and dx. The dy and dx represent infinitesimally small parts on the curve. To add up all of those small parts, we need to take the integral. We take the integral from points A to B, any 2 points on the curve. Here's where the algebra gets involved. Now we're going to factor out a dx. The dx is going to come out of the square root sign, and we'll have it on the outside. And with a little rearranging here, we should end up with a clean-looking integral in standard form. And this, ladies and gentlemen, is our arc length formula.
So today we learned how to find how far the basketball actually travels through the air using calculus. Do you remember what formula we used? Great!
Hey, if I'm not in your music video, I'm gonna smack you so hard.